Archimedes of Syracuse, born in 287 BCE, is widely regarded as one of the most influential mathematicians, engineers, and inventors in history. His contribution laid the groundwork for various scientific fields, including mathematics, physics, engineering, and even astronomy. Although Archimedes' life is shrouded in mystery, with little reliable biographical information available, his scientific legacy is irrefutable. He revolutionized the understanding of geometry, developed fundamental principles of levers and buoyancy, and invented a variety of machines that had both practical and theoretical significance. His work has not only stood the test of time, but has also influenced generations of scientists, mathematicians, and engineers. One of Archimedes' most famous achievements was his work in geometry. He developed methods to approximate areas and volumes of curved shapes, which were groundbreaking at the time. Beyond the specifics of his mathematical discoveries, Archimedes is also known for creating new methods of mathematical reasoning. One of his most significant contributions was his method of exhaustion, a precursor to integral calculus. The method involved approximating areas and volumes of complex shapes by inscribing and circumscribing polygons with ever more side. Archimedes is perhaps most famous for his work in the field of physics, particularly with the principles of buoyancy and the mechanical advantages provided by levers. The principle of buoyancy, often referred to as Archimedes' principle, states that an object submerged in fluid experiences an upward force equal to the weight of the fluid it displaces. This discovery came to Archimedes while he was tasked with determining whether a crown made for King Hero II of Syracuse was made of pure gold. Archimedes realized that by submerging the crown in water, he could compare the amount of water displaced by the crown and by an equal weight of pure gold, thus determining whether the crown was made of a mixture of gold and silver. The famous story goes that Archimedes was so excited by his discovery that he ran through the streets of Syracuse shouting, "Eureka!" which means, "I have found it." This principle of buoyancy remains fundamental to the fields of fluid mechanics and engineering, particularly in the design of ships and submarines. The concept also had broad implications for understanding of density and the properties of materials. Archimedes' work with levers is equally significant. In his treatise of the equilibrium of planes, Archimedes demonstrates that levers can be used to magnify force. He famously said, "Give me a place to stand, and with a lever I will move the world." This statement embodies the core principle of the lever. A force applied at one point of a rigid bar can be magnified at another point, depending on the positions of the fulcrum and applied force. The lever became one of the simple machines that formed the basic of classical mechanics, and Archimedes' insight into its operation were foundational in the development of mechanical engineering. Archimedes was not just a theorist, he was also a practical inventor. His inventions were wide-ranging and included devices for defense, transportation, and water management. One of his most famous inventions was the Archimedean screw, a device used for raising water from lower levels to higher levels. The Archimedean screw is still used today in various forms for irrigation and drainage systems. The invention demonstrates his ability to apply mathematical and mechanical principles to real-world problems. Archimedes also designed war machines for the defense of Syracuse during the Roman siege of the city, which included catapults, cranes with hooks that could lift enemy ships from the water, and even a giant claw designed to capsize enemy ships. Archimedes' influence can be seen throughout history of science and mathematics. His work on geometry, mechanics, and fluid dynamics laid the foundation for later scientific advancement. The study of levers, pulleys, and other simple machines formed the basis for the study of mechanics, which later influenced the development of classical physics by scientists such as Galileo and Newton. Archimedes' principles were also integral to the development of modern engineering. Concepts like mechanical advantage and buoyancy were not only theoretical insights, but also had tangible applications that influenced the development of technologies from the Renaissance to present day. Even in the field of mathematics, Archimedes' method anticipated key developments that would not be fully realized until the 7th century with the rise of calculus. Archimedes was a true polymath whose discoveries and inventions continue to shape the world today. His understanding of mathematics and physics revolutionized the way people view the natural world, and his inventions played a key role in the technological and engineering advancement. While Archimedes lived over 2 million years ago, his work remains as relevant and influential as ever, continuing to inspire new generations of scientists, mathematicians, and engineers.